Hi, my name is Brandon Hines. This is my second Lab 2.2 for the cyber class at St. Bonaventure. Today we're going over nmap. Um, so I set up a exploitable uh, Linux server on my virtual machine on my computer, and I put both of them to bridge network so they had their own independent IP addresses. And then I used ifconfig on the other uh, Linux server, the Metasploitable server, to find its IP address, and it was this. So then we go through the different types of nmap commands that can be run, and we'll talk a little bit about them. So first one is dash p dash, which is going to go over all the ports. That's why you see, I think they're actually in all of them because it's considered one that's commonly used. No, it is not. So there's over 60,000 ports, and dash p dash tests all ports between 1 and the max instead of normal nmap scans, which tests only the top 1,000 most popular used ports. So this is going to scan all of them. It took 1.96 seconds. And it gave us ports like these that are seen as open that we probably wouldn't get in a regular scan. Then we do a -A scan, which gives us a lot more information about all of the different ports and what's going on with them. It took 72 seconds. This is a much longer scan, so not something that I would use if I wanted to get information quickly, but it also gives me stuff like anonymous FTP login is allowed on this server, and that's something that the online textbook said that you should disable because it can be exploited. Linux Telnet, that was also shown in dash p dash, and this one is very time-consuming scan. So we're going to a normal scan. This is the three-part handshake because TCP scans initiated a three-part handshake. So this does all three of the parts of the handshake: the SYN, and then it receives the SYN ACK, and then it sends the ACK back, ACK, to keep the port open, or a REST. I think this one sends a REST at the end to close the port. But this is the full handshake that's completed. And then this is the fastest one, taking 0.16 seconds. After that, you can see I made a mistake here, not writing this as sudo. This is a half open scan where the ACK isn't sent. So it's how the textbook describes it is it's like ding dong ditching. It takes a little bit longer for whatever reason. Maybe it could have been the network with 6/100ths of a second in difference. That could be anything. Same, all the ports open. And then we move down to SX, which is the Christmas tree, where it sends all of the parts of the packet, the TCP packet, are open, and the server replies with different things depending on if it's open or closed. It will send a REST if it's closed, I believe, and it will send a response along the lines of, we don't really know what you're trying to send us if it's open. So you can use that to be a little bit sneakier to try to scan ports on a server. And then we're going through SF, which is a fin scan. This one took 1.62 seconds, a little bit longer than the one before, but hundredths of a second could just be network inconsistencies. SN, this is a null scan, 1.56 seconds, all about the same here. The O scan -O is going to give us the operating system. So right here, we're going to know that it's running Linux 2.6.x, kernel, some of the OS details, and that the network interface card is virtual through an Oracle virtual box. So we know this thing is running on a virtual machine using this specific scan. And that's important information because we may not want to attack something that's on a virtual scan. It could be a honeypot. Also, getting the information from the operating system and what's running is important because then you can look specifically on something like Metasploit and figure out what specific vulnerabilities can be exploited for this specific operating system. Then we're going to go down after this, and this is our longest one. This is the UDP scan, which you can see took 1,013 seconds. And it showed only 4 ports open. The reason why UDP scans take longer than TCP scans is because there isn't a 3-part handshake. It's just a call and response. So you don't necessarily know if your call isn't getting a response because of a network issue or because the port is closed. So writing off each one of the potentially over 60,000 ports takes multiple calls to the port, and you need to make super sure that it's closed. So 4, 5, 6, 7 times it needs to be pinged that specific port before you can totally write it off. Because there's also the event that, unlike TCP, you could send the call and get no response, and that doesn't mean that it's necessarily closed. That could mean that there is a network issue. So that is my lab 2. If you have any questions, please email me. I appreciate your time. Thank you.